Okay, so we are going to determine whether a certain piecewise function is both continuous and differentiable. So here is what I am given, 2x minus 3 on the interval from -1 to 0, and x minus 3 on the interval 0 to 4. Okay, great. So first of all, we have to decide if this is continuous and differentiable. Well, we know that if a function's continuous, then it is possibly differentiable. So I first have to prove continuity. And we're going to go through the three conditions of continuity. Now, we are concerned at the point 0. So, does f of 0 exist? So when I plug in 0, I get 0 minus 3, which is -3. So yes, it exists. Notice I'm reviewing with you how to find continuity. Now, does the limit as x approaches 0 from the right of the function, will this equal the limit as x approaches the left? Well, as I approach 0 from the right, that would be 0 minus 3, which is -3. And as I approach 0 from the left of the function, that would be 2 times 0 minus 3, which also is -3. So then we know that this function is continuous because f of 0 is equivalent to the limit as x approaches 0 of f of x. So all three conditions are met. Now I have to go to prove differentiability. Now, differentiability means that the limit of the slope equation for the slope of the tangent of the line exists. So we must find the limit of the slope formula. Now I'm going to make you do the one that you're not as comfortable with as h goes to 0, and we're going to pick a point a little bit greater than a, subtract it from f of a all over h. So will this limit from the left be equivalent to its limit from the right? Okay, so first of all, let us find the derivative at 0 from the left. So that would be the limit as h goes to 0 of, it's 2 times the quantity, 0 plus h minus 3, minus, then we plug in 0 into the function, which is a -3, all over h. Okay, let's go ahead and simplify this and find the derivative. So the limit as h approaches 0 is, we're going to get 2h minus 3 plus 3 all over h. So we end up with the limit as h approaches 0 is, we get 2h over h. H is reduced, so we end up with 2. So the derivative of this piecewise function as I approach 0 from the left is 2. That means the slope of the tangent line is 2. Now we have to find the derivative as we approach 0 from the right. So we'll have the limit as h approaches 0. Now we're going to look from the right, so it's x minus 3. So the function would be then 0 minus 3. Oh, I'm sorry, 0 plus h. Oh, sorry, guys. 0 plus h minus 3 minus 0 minus 3, which is -3, all over h. So we get the limit as h approaches 0, and then we get h -3 plus 3 all over h. And so then we can see that the derivative then, as we approach 0 from the right, we plug in 0. Well, we see that the -3 and the 3 reduce, h over h is 1. So the slope from the right is 1, and the slope from the left is 2. So therefore, this function is not differentiable, but it is continuous.